Hello, this is Dr. Darbro. This is where we're going to step back from everything that we've learned and actually work a couple of problems. And I know this is always when I was a student many moons ago. This is my favorite part. Get out of the lecturing, get out of learning new material, and actually try out some things that we had been taught. So this is the way this is going to work. I'm going to jump around from PowerPoint to the graphing calculator to the blackboard. So just bear with me. It's going to be a little bit choppy, but I think this is the best way to present this this video. So first of all, what I'm going to do is I'm going to give you two problems, and they're going to be presented on PowerPoint. Then we'll jump out of the PowerPoint, and we'll use the calculator and actually come up with the answers. So that's the game plan. So let's see how this works. All right. And guys, remember, you can pause me, you can stop if you want to write this stuff down, which I think would be a really good idea. Also keep in mind that you've got a notebook to turn in for part of your grades. So the National Center for Education Statistics monitors elementary and secondary education nationwide. Looks like in 1996 they used that as their baseline. And also in 96 they saw that 31% students reported that their mother had graduated from college. So again, keeping this as the baseline. In 2000, responses from 8,368 students, there's a typo there, so please forgive me, indicate that this figure had increased to 32%. Is this evidence of change in education level among mothers? Now guys, the 32% is considered our sample. The 31% is the baseline, or what's considered the current status quo. Just because your sample is higher than your 32% is higher than your 31% doesn't mean that the difference is statistically significant or important to us. So what we have to do, we have to remember that comparing a sample to a population, we have to let the process of hypothesis testing take its run its course. Okay, so some questions we're going to have here. First question: write the appropriate hypotheses. B, perform the test and find the p-value. C, state your conclusion. And D, do you think the difference is meaningful? So now let's just go back. When we think about writing the hypotheses, what does it say? I want to go back to the first slide. I want to go to the second slide. Is this evidence of a change in education level among mothers? So again, the last sentence, is this evidence of a change? And notice it doesn't say, does this indicate that the education level has increased? It doesn't say, is this evidence that the education level has decreased? It just says, is this evidence of a change in education level among mothers? Okay? Now, the next question, I don't know if any of you are considering law school, but in 2007, the Law School Admissions Council reported that 66, right at 2/3, of law school applicants were accepted to some law school. A training program called LSatisfaction, which is geared toward improving the attractiveness, if you will, of law school applicants, claims that 163 of the 240 trained in 2007 were admitted to law school. Now we see a lot of training programs like this with, for example, ACT, where, considering the high stakes of ACT, there are weekend, even month-long programs where the program is geared toward increasing ACT scores. Well, this one is geared at increasing the likelihood that the student gets accepted into a law school. So focusing on the question here in the last sentence, has LSatisfaction demonstrated a real improvement over the national average? Now guys, it's kind of tricky there, but improvement to me indicates that we're looking at a higher percentage. Okay? So the questions here, what are the hypotheses? Find the p-value. And would you recommend this program based on what you see here? All right, gang, what I want to do now is I want to end the show, not the video, but end the PowerPoint presentation. And I want to go over to Air Server, and let's start answering some questions. Okay, so talking about the educated mothers, again, is this evidence of a change in education level among mothers? So guys, in my opinion, part A, so we're dealing with a percentage, and the baseline was 31%. Okay, don't get distracted, okay, because it's tempting to try to put that 0.31 or 0.32 in here someplace. Remember, whatever goes as our parameter will also go, and our value will also go in the alternative hypothesis. This will always be equal to, being the null hypothesis, but the alternative hypothesis, we have to choose the inequality that represents the motivation for the test. So is this evidence of a change? Guys, I think clearly we are at 0.05. I'm sorry, we're clearly at not equal to. I'm thinking actually ahead here that we will test at 0.05. Got ahead of myself there. Okay, so again, the null hypothesis, P equal 0.31. The alternative hypothesis, because we're just testing to see if there's an evidence of change, is going to be not equal to 0.31. Okay? All right, gang, perform the test. Now, the important thing here is our Z statistic. And our p-value. So I'm going to get out of this and get the graphing calculator. So guys, what we do here is we conduct what's called a one-prop z-test. Our p-value is 0.31. There were 32% of the 8,368 students. Now we got to be careful here. When we hit enter, notice that we're going to get something that's a decimal. Well, X is always a count, so we're going to have to change that to 2678. If we leave that as a decimal, our calculator will give us an error, which is not cool. So our N is 8368. We're testing not equal to, so make sure that's set appropriately. And we will calculate. Okay, so we see that our Z is 0.198 and our p-value is 0.047. So go back over to the 1.98 and our p-value is 0.047. So our p-value is less than our alpha, barely, which leads us to part C. State your conclusion. Well, since our p-value is less than alpha, we reject our null hypothesis. Now, a good way when you're learning to interpret this is if you reject the null, draw a line through it, and there's more evidence for the alternative. So by rejecting the null, we conclude that the alternative, where the p is not 0.31, is more aligned with our sample results. So part D, do you think this difference is meaningful? Yes. Our test is statistically significant. And it appears that the percentage is indeed higher. Now, what I would recommend is, and the question wasn't asked here, but I would recommend part E, calculate a 95% confidence interval to get an estimate on what the percentage actually is raised to. But we weren't asked that, so we don't have to worry about that just yet, okay? All right, gang, question number 2. This goes back to the LSAT question, or I'm sorry, the L satisfaction question. And the first question, what are the hypotheses? Well, our null hypothesis here would be P is 0.66. And remember, the letter and the number always come down into the alternative hypothesis. But the last sentence in our question says, has L satisfaction demonstrated an improvement? Well, guys, it can only demonstrate an improvement if the percentage is higher. All right? So, question B, calculate the p-value. So I'm going to go to my calculator to do that. We're going to calculate p-values by hand, but when we're working problems, we'll use the calculator. Okay. So this worked before, so let's try it again. So come down to number 5. So our p-value is 0.66. We have 163. Out of 204. And we're testing greater than. And we'll do our calculation and get our p-value. Now, gang, at this point right here, it's really easy to get sloppy and get the wrong answer. Remember, and you should hear Dr. Darbro screaming at you at the top of my lungs when you get ready to make this mistake. P-values of probability. Probabilities have to be between 0 and 1. 1.39, which is our p-value in this case, is not above or between 0 and 1. But if we look out here, we'll see that we have scientific notation, which tells us to move the decimal place 5 places to the left and get our correct answer. So guys, at the end of the day, our p-value is going to be 0.000014. Now guys, a low p-value is strong evidence against H sub O. Strong evidence against H sub O. So if we go back over here, I'm just going to really mark that out, kind of dramatic here, because the result from our study indicates that there's strong evidence against the null hypothesis, yielding strong evidence for the alternative hypothesis. Okay, part C, would you recommend this program based on what you see here? Absolutely. It appears without question, or there could be some question according to, whether or not we have a random sample, but just based on the numbers that we've crunched here, the low p-value, strong evidence against the null hypothesis, indicating that the percentage of students who enroll in a training program called L-Satisfaction appear to be accepted at higher rates to law school than just those who don't. Now, what I'd like to know here, and I'm going to go ahead and follow this through, I'd like to go ahead and calculate a 95% confidence interval to just see, based on probability, where our results actually lie. In other words, what percentage of students who take the training program appear to get accepted into law school. Now this is kind of cool, guys, because we did a 1 prop Z test, and if you remember from a few weeks ago, we also know there's a 1 prop Z interval, which corresponds to a 1 prop Z test. It's also kind of cool because you'll notice that the numbers have already been imported or exported, however you want to look at it, from the test, because at the end of the day, it knew you were coming, because it is customary to construct a confidence interval when conducting a test of hypothesis. So guys, it appears from our sample that the percentage of all students who goes through the training program, and I'm going to get out of here and go back over to the screen here, is with a 0.95 probability contained in this interval. So it appears that the training program, again, keep in mind that 66% was kind of the status quo. So the minimum is increased by about 8%, and the maximum is increased by about 19%. So it appears that the training program increases the likelihood of a student getting into, well, no, that's not right. It indicates that the percentage of students who get accepted into law school increases about 8.4% to 19.4%. And all I'm doing to get these values is just taking these numbers and subtracting 66 from them. All right, gang, that's it. It's the end of this video. Have a good one.